RUEI, image processing control, and omnidirectional camera. So last time we started here, and this is called image staging. Well, is this the only way? Is this the only way we get an omnidirectional camera? Omnidirectional image.
No.
Is this the only way? So, for example, I want to get the omni 360 degree. Okay, one photo, and the staging. Is this the only way? And what's the other way? Get the 360.
But there are technically three ways. One way is like rotating whole robot with fixed camera. One way is rotation camera, like the wider.
Exactly.
And the third one is multiple sensors.
Exactly. So technically, there is a five way to do that. And I'm showing you the rotating the camera. And we did it once in our lab. And okay, so this is the camera rotating configuration. Did you see this camera? This is the PDZ camera, 180 and flip another 180. 这个你在家乐福都可以买，特力屋都可以买得到。Actually, you can buy in the local like a carry forward. This is the sound phone because we did it in the university. So they rotate. This one is called rotate. Okay, 180 image and flip back. Oh, another 180. So this is the one students for doing H360. So robot doesn't need to move. So once you get 360, so through this image and go approach to the object. So even for the image in the back. So this one, I'm going to show you these how this is work. This image things. It's which you are going to do it similar. Okay, so two pictures. That's the feature point, which last time Hong Jun said grab the feature point, and a pair, and measuring the distance. So that's what you're going to get, 360 degree image through this UAV, okay? And next will be the other configuration. I put it in the slide, the teaching slide. RGBD camera. Well, I think that's Thomas said it before. RGBD camera. Oh, Angela, we have an RGBD camera, right? The UAV. Oh, I see. Okay, good. And this RGBD camera, 最后我们那个 RGB camera 有几个？
一个现在。
然后呢一个呢？
另外一个的话，你没有，
可以拿来做几个？啊？
我也去拿。
或者你现在是真的要回去，不用特别问你。好，那你两个过来。
等一下我过来确认一下。
OK， 好。So there's an RGBD camera. Everyone can tell me the principle of RGBD. Hold on a sec. I think originally you want to use RGBD.
Principle?
Well, yes.
It uses red, green, blue, and depth.
No, I just say the principle. How does it work?
It captures those colors. I don't know what you mean by principles in this case.
Principle, how does it work? For example, laser rangefinder, time of flight. oh, you shoot a light and measuring the distance, and the laser rangefinder you shoot into the obstacle and bounce it back. So D equal to velocity times the time, the t. So the range will be 2 over d. So that will be 2 over vt, and you can measure the speed, and you just measuring the time divided by 2 will be the range. Principle of a laser rangefinder or a sonar. So, yes.
Did you say anything about 2 laser pointing? The further down, the further away, the further the 2 points up. Did you mention about something like that?
No, that's not the RGBD.
It's not for RGBD.
No. RGBD, remember last time I said I invented it, and Thomas doesn't believe in it, and I think he still didn't believe in it, right? Even I showed him the paper, and otherwise he will remember, oh yeah, this is the principle, yeah, you invented it, right? It's okay, I'll try hard to convince you, okay, to promote, because this is my hypothesis. Why you need to know the operation procedure? Because once you operated it, because actually I built this RGBD camera, so I know the problem. It's really have a problem, and so that's why I wanted you to know what kind of problem it will be. Okay, and that says going to video sensing, and okay, this is the paper. Okay, this is the configuration. This is the configuration of the RGBD. So one regular camera and the one structure light. So you project the stripe in there, and the shift of each stripe. How much is the shift? Is proportional to the depth. To the depth. So you will see simply to say it's this. This is the principle. Okay. The shift of the stripe in the image is proportional to the height of the obstacle, of the object. That's it. That's the RGBD. So the measurement, that's why it says RGBD, and the depth is measuring by the structure light. Project a structure, project a light laser stripe. So it will shift in the image. So this shift is proportional to the height. Okay, then what's the problem with this measurement? Because last time you say we're using RGBD to measure, what is the problem? Yes. Because I really started from the component level to build it. So that this is the paper is I'm trying to solve this problem. Okay, let's go back to the model. Okay, so this is the triangulation. So the formula is here. So the height is proportional to the tangent of the incident angle. This is the working distance, this is the focus length, and this is the shift. This is the shift of the image. So this is a constant, and focus length, assuming it's a constant, working distance how far to the object. So working distance, and the laser angle, and the focus. And this is the shift, the stripe in the image. For RGBD camera, it's just only invisible light. It's the same thing. They project a light to measure. So First problem, the working distance is a variable. Did the RGBD camera measuring profile? Second, the laser. Also, if you shooting that laser line, project to your body, technically, they need a focus because it have a lens in front of laser. So you need to keep it tuning for its focusing. And do you think with that chip level, do you think they detect that with that chip sensor? I don't think so, because that's a cost. It's not like a technology, not durable. It's cost. So basically, they assume the focus is not changing. The working distance is fixed. So in this case, you will not be very focused. If it's not be very focused, what will happen? Okay, everyone see? When I draw a line, because you are measuring two lines distance. This is laser line, the shift. Just pixel to pixel. Yeah. Everybody is confusing. Oh, yeah, just measuring the distance. Assuming this is only one point, right? And that's the point. But this is line. There is a width. It's not a single point. So basically, it's a stripe. 这个 line， 你如果放大在 image 上看，它是一条带子。It's just like this pen. When I draw it, you take a picture. You think only one pixel? You think only one pixel? 那你是尽量哪一点？我现在就讲说，你把这条线给截出来，你都是问题。You just draw a line, and you take a picture. You give me only one line. Basically, 这里的浓度，这每条线你们浓度就都不一样。就是你像一个油漆嘛，你这样刷子一刷，你用笔，你这样写一条线，有没有墨水？这个墨水会散开来。If you use the pen, there's ink, right? 有ink，你现在用张笔，这个墨水是不是会散开来？光也是一样的概念呢。So if there's a light, it goes through. The light is not a single point. So basically, it's straight. So we need to find the peak point. So my paper is trying to solve that issue, technical issue. RGBD have a problem. It's not that accurate. So you need to combine with a laser rangefinder. Should combine with laser rangefinder. Because the people is using RGBD, you think it is accurate. No, it is not. Alright, so then next is LiDAR. This is LiDAR. Well, I think that Jacob know what is LiDAR. And tell me operating principle.
Basic principle is
Time of flight.
Yeah, like it's using same technique as time of flight. There is
A light goes through.
infrared light.
So velocity, measuring the time, coming back, and divided by 2, it will be the range. So basically, it's one laser rotating for 3D. So that's the LiDAR's principle for 3D building the cloud, point cloud. So that's why they say the point cloud, and measuring the range or building the environment. So I want you to do this 2D mapping. And this one is I bring the laser here today. You can borrow from me, okay? And using neural network, 2-point pixel separation. This is what I mean, pixel separation, and this is range to object. So a camera here. You can even attach it to your camera, or you attach it to all ground mobile robot. Well, technically, I only do the underwater because you will see more the effect because of the water. So make it your model. I mean, it's a much bigger uncertainty. If in air, probably not that bad. But in the water keep changing. So in this case, the relation, okay, see, that's what I'm experiencing always do. You measure distance. 然后呢，每一个点这样子一个 pixel separation 一个 range, pixel separation 一个 range, pixel separation range. So in this case, input into the neural network. One pixel separation, one range, pixel separation, one range, pixel separation into a neuron, and get the relationship. Well, the laser is here. The laser is there. So the 8 is the structure light, which is this one you need to work in the lab. That's what I'm talking about, this RGBD. And we set up in our lab, so you project the laser stripe, and you just get the map. Okay, same. I'm not talking about processing, just sensing. Just get the image, then you got. Oh, and send it to the Google digital machine with a different object. Okay, that's just said. Which object is have a higher height? This one or this one? The height. This one. So that's the experiment I want you to do is turn on our structure light. Just turn it on the light and put it here and get 100 image. Because when you do it, the light will shift, right? So there will be pattern. And another, take another 100. A pattern and send it to a digital machine for training. Yeah. So that means to classify. Oh, this pattern is taller. This one is shorter. The depth is less. By using the structure light in our lab, you just turn it on and put maybe 3 objects, 3 class into it, and then send it to the digital machine. 就是把结果网打开嘛，来问你，这个东西比较高还是这个比较高？哪个比较高？这个比较高。好，那你现在就分3类，高、中、低的。好，结果网打上去，哦，100个 image， 然后再打一个100个 image， 这是高的，是低的，然后送进去过去。你今天就用500个 RGBD， 你看得出来哪个高跟低？如果你这样看，你看得出来吗？所以呢，就这样子，但是打光上去，structure就来，and then send it to the digital machine. Well, so this one, those are, well, the purpose of this will be more like letting you to familiar with our equipment. That purpose. So actually, this originally I put it in the very beginning, trying to let you to get familiar what the toy we have in the lab. Okay, so okay, using for your final project. But since this semester, we're changing this scenario. Originally, I wanted to use this equipment that you can think for your final project what you can use. But this semester, we fixed the scenario. So, well, but still, it doesn't matter. You can go experience and to learn what the toy we have, and I know, for your future, right? For example, okay, developing his own ship, navigation, physiology, navigation. You didn't draw that data through the Excel, right? Just kidding, the major. So it's good. Okay, so let's do the work. Oh, I mean, okay. Oh, I didn't read over there. I was very busy, so I didn't check. Like, did you send me to check the similarity things? don't change everything. You know, something, for example, you say, oh, the name is similar, you cannot change the name, right? Of course, I mean, you mentioned, oh, me if I'm repeating, that's the similarity. I didn't say, oh, every similarity you have to fix. Only the fix, for example, the writing the document name part. So, for example, the reference part, yes, similar is exactly the same. So it doesn't have to. I was talking about it to them. I mean, they taking my courses before. It's two gentlemen, and they are very ambitious and to publish their paper.